Dear participants, is my voice clear? Hello, welcome, Professor Hüseyin Can Bolat.
Thank you.
Yes, sir. It's audible, sir.
Dear participants, welcome to 5th International Congress on Human-Computer Interaction, Optimization, and Robotic Applications. We are in session 6.1 now. Before starting, let me give you some information about the Congress. The Congress aims to bring scientists, experts, instructors, non-governmental organizations, and private sector representatives together to share and discuss theoretical and practical knowledge in a scientific framework. In addition to cutting-edge paper presentation in human-computer interaction, optimization, and robotic areas, the Congress serves as a multidisciplinary platform for discussing current issues in the engineering areas. Our Congress is supported by IEEE Turkey section. We have a special guest today. Our keynote speaker is Professor Hüseyin Can Bolat. First of all, on behalf of organizing committee, I would like to thank you for your scientific contribution to the Congress. I would like to inform you about a change in Saturday's keynote speaker, Professor Tanupre Chaudhary. He will make his presentation today at 12 o'clock, just after completing our first presentation, a presentation of Professor Hüseyin Can Bolat. Once again, I would like to remind you that please don't leave the session after completion of first presentation. Before starting his presentation, let me give you some biographical information about Professor Hüseyin Can Bolat. He graduated from Middle East Technical University, Electrical and Electronics Engineering Department in 1989. He received his MA from Middle East Technical University in 1993 and his PhD from Clemson University in 1997. He started his academic life at Middle East Technical University in 1989 and continued at Mersin University. After taking part in the faculty of Mersin University between 1998 and 2012, he was appointed to staff of Ankara Yıldırım Beyazıt University in 2012. He still works in the same department. The number of journal articles and conference producings is more than 40. He has been a chapter writer and editor of books in the fields of robot systems, electrostatics, and Lagrangian dynamics. He provides postgraduate and doctorate consultancy in the field of defense technologies and occupational health and safety. He continues to work in the fields of control and command systems, robotics, mechatronics, and signal processing. Since 2016, he has been the head of Department of Defense Technologies of the Ankara Yıldırım Beyazıt University Institute of Science and Technology. Professor Can Bolat, if you are ready, you can share your screen and start your presentation. You have 30 minutes at most to complete your presentation.
Okay, thank you very much. Let me let me see it. Is it okay? It isn't.
We can't hear you clearly, but
Okay, I also can't see. I don't know why.
we can share your screen. We can see your screen. You can start.
Okay, you see it?
Yes, we can see.
Okay. So it is at the end. Let me take it back to beginning and make it like that. Okay, I will present one of our recent studies. It is simply prediction of Turkish Sign Language alphabets utilizing deep learning methods. This study is conducted by Ahmet Kasım Paşa under my supervision. Okay, first of all, the contents of the presentation can be summarized as introduction to the problem and so on. Okay. The problem can be described as we can see that there are people with disabilities in the society, and the technology offers solutions for disabled people. In our case, we will deal with the deaf people, and the fact is about actually more than 400 million people in the world are deaf, and communications between deaf people and the normal people is always a challenging task. You see, 87 million deaf people around the world use sign language for their communication with the other pupils, or with themselves and other people. Sign language helps deaf and the dumb people to communicate with other people. Unfortunately, not all people understand or recognize sign languages, including myself, by the way. 72% of families do not sign with their deaf children. Again, they have deaf children, but they cannot use sign language to communicate with them. There are a suffering among deaf people at the work or when they perform for their daily tasks. Okay, the basic problems can be seen as the communication with the deaf people and normal people, between the deaf people and normal people. Normal people do not know the language of deaf people. Simply sign language are not known by most of the normal people. Also, but deaf people cannot speak. Okay, this ability cannot be removed because deaf people should live with this disability. However, normal people can be made learn a sign language or can be made through technology to understand the sign language. Okay, so what is the solution? The traditional translators cannot translate the sign language. Actually, the traditional translators simply uses the sounds or speaking languages from one speaking language to another. Therefore, the translation of sign language is not possible with traditional translators. The solution is to create a system that can translate sign language to natural language. Okay, as a solution, we can make the normal people to understand the sign language using new technologies such as deep learning. Sign language mainly depends on hand movements, or it's simply called hand gestures in literature. Sign language is like natural language that varies among countries. What does it mean? Every country has its own sign language and may not be compatible in most respects, in some aspects, sorry. There are two types of input modalities in sign language systems. First one is visual modalities. They use cameras as their sensors. Visual modalities use other types of sensors. For the device modalities, we can see that device modalities mainly depends on sensors that send signals as an input to the system. Some examples are cyber gloves, deep motion controllers, and electromyography systems. For visual modalities, they depend on cameras to capture the images of the movements and to be an input to the system. So we use mainly cameras, or more developed, more enhanced solution, Microsoft Kinect. It has a depth sensor, camera, plus IR projector. It has, and color camera also. Sign language recognition systems they consist of two steps as follows: input step and recognition system. The recognition system receives the input and converts signs to text or speech, as shown in the figure. Our study focuses on Turkish Sign Language alphabets. The input modality is vision-based because the cameras are available everywhere. We will try to use the cameras in our system. The methodology of this research consists of collecting the data set, building the DL model, acquiring the results after training. Okay, we use some data set here. But it is not completed yet. This is the presented results are the preliminary results of this study. Okay, so collecting data set is the first step to build a deep learning system. Our data set is thresholding Turkish Sign Language alphabets, so threshold values can be seen here, you see. Why are we using thresholding? It is a widely used method because there are some benefits gained by the thresholding, like image segmentation, object detection, noise reduction, feature extraction, image enhancement, and binary representation. Widely used thresholding techniques are binary inverse, and OPSO. Okay, we use a data set. The characteristics of the data set are dimensions of the images. Normally, the data set includes the images. The dimension of these images are 224 times 224 squares is a square. The dimension of images after resizing 64 times is 64. And we use approximately 13,000 images in different conditions. What does it mean in different conditions? For example, different distances from camera, different lighting states, or different backgrounds, and so on. The used library is OpenCV, and the division ratio for training 80% for training and 20% for validation and testing are used. Okay, we use the model, deep learning model called as convolutional neural network. It is a deep neural network model, or it's a type of deep neural network that is particularly appropriate for image classification missions. A CNN, or convolutional neural network, consists of convolutional layers, pooling layers, the activation layers, the fully connected layers, and the lastly, fully connected layer output. Okay, convolutional layers extract features from the input image and generate feature maps that highlight the different patterns in the image. The pooling layers decrease the size of the feature maps by choosing the largest value in a limited area. Activation layers, which apply a nonlinear function to the results of the prior layer. The fully connected layers utilize the features extracted after flattening them to a one-dimensional vector, and the output layer is passed out as fully connected FC layer. Output is passed out of a softmax activation function to find the class probabilities. Okay, this is the image, or this is the block diagram of the typical convolutional neural network architecture. The structure of the CNN, we use three different CNN structures. The first one consists of three convolutional layers with max pooling and ReLU activation function, then flatten operation, and fully connected layers with softmax as a classification function. So we have input signals in the input layers. We have input signals, simply use cameras, feature extraction, convolutional nets, ReLU, max pooling, and it has three layers, as you see here. First one, then the output of the first one is fed to the second one, and the second output of the second one fed to the third one. As a result, the output of the third layer fed to the output layer through fully connected neural network ReLU activation, and then fully connected neural network stuff. Okay, the results of these functions, what I mean is the results of the CNN1 model or CNN1 structure. The optimization algorithm, learning rate, those function category, and the evaluation metric is the same for all architectures. Therefore, I write down them as small letters, and I will not repeat them after, for the other results. Optimization, we use the Adam optimization algorithm. Learning rate is 0.001. The loss function is categorical cross entropy, and the evaluation metric is the accuracy. So for all structures, these will be valid. The accuracy rate of the CNN1 is found to be 88% and 89.70%. For 88% part, we see 300 epochs with a loss of 0.14, sorry, 0.41. For 89% accuracy, we have 0.42 loss for 500 epochs. As you see, for between the two cases, I mean between the 300 epochs and 500 epochs results, there's not so much enhancement. Simply from 88% to 89%. So also the loss is from 0.41 to 0.42. So the number of epochs, increasing a number of epochs, is not beneficial in case of CNN1. Or we can say that 3 to 500 epochs will be enough for enough accuracy for CNN1. Okay, CNN2 structure consists of 4 convolutional layers with max pooling and ReLU activation function, then flatten operation, and fully connected layers with softmax as a classification function. This structure, the CNN2 structure, has uses dropout layers after each convolutional layer and max pooling layer as shown in table 1. You see, layers are listed here. There are 13 layers. The shape of the output is given like batch size and so on. So the shape will become simpler. Number of parameters, you can see it here. Total parameters are 186,000. Trainable parameters are same. Non-trainable parameters, there is no non-trainable parameters. Okay, based on this structure, we simulate the CNN2 and get some results. Actually, with dropout layers, the system becomes overfitting. As a result, we proposed, or we tried to remove the 2 dropout layers, and the results are given here as 97% accuracy, and the loss is around 0.01 or 0.099 for 100 epochs. You see, we use less epochs compared to the CNN1 structure with a smaller loss, but higher accuracy, almost 97, more than 97% accuracy. Actually, in this case, we try to use different dropout rates. 0.5 and 0.25 dropout rates are were used, and then the best result is obtained with the 0.5 dropout rate. The results given here are for the 0.5 dropout rate. Okay, there is another structure we used, we tried. This, we call it CNN3. It consists of 5 convolution layers with max pooling and ReLU activation function, then flatten operation, and the fully connected layers with softmax as a classification function. You see, in between these structures, simply we use 3 convolution layers in the first CNN1. In CNN2, we use 4 convolution layers, and now we use 5 convolution layers. This structure uses also one dropout layer after dense layer, as shown in table 2. See the dense layer and dropout layer and more dense layer. Okay. So we try to use 3 convolution layers at the input of the model and 0.5 dropout rate at the output with the same optimization algorithm, learning rate, and so on. The accuracy rate of CNN3 is 97%, more than 97%, and the loss is 0.097 for 70 epochs. You see, increasing the convolutional layers, the number of epochs for the accuracy becomes smaller. Okay, let us discuss these results. As a result, we see that the CNN2, after removing some dropout layers, is better than CNN1. Without dropout layers, the CNN2 was overfitting and it was not useful. However, using or removing dropout layers, the results becomes better than CNN1. First of all, CNN2 provides the acquired accuracy after 100 epochs compared with the around 500, more than 500 or 300 epochs for CNN1 to supply a lower accuracy. Actually, after 500 epochs, we got around 89% accuracy for CNN1. However, for CNN2, after 100 epochs, we got around 97% accuracy in CNN2. But after removing the dropout layers, with the dropout layers, CNN2 is not good. However, with the removed dropout layers, CNN2 is better than CNN1. Also the CNN3 we tried, and we see that it is better. It gets better results for compared with CNN1 and CNN2 structures. Actually, it provides acquired accuracy after 70 epochs compared with 100 epochs. Using less epochs, we get higher accuracy or required desired accuracy. Therefore, it is enough to use 70 epochs for training the model. CNN1 and CNN2 need approximately 500 and 100 epochs to supply a lower accuracy than the CNN3. Furthermore, we tried another learning rate with CNN3, 0.001 compared with the 0.0. Sorry. Instead of 1,000, we used a 1,000 1/1000 learning rate with Adam Optimizer, but the model does not give a good accuracy after 200 epochs. So, using a better, tighter learning rate gives no accuracy, gives no good accuracy, because this is another result for CNN3. We did not give this result actually here. Therefore, the best learning rate it seems to be 0.001 in this case. Actually, the 0.001 learning rate was used for each of the CNN structures. I mean, CNN 1, 2, and 3 are used 0.001 learning rate. Trying another learning rate at least in CNN 3 did not give us good accuracy. Okay, this is a table for summarizing the results. So the work for this study is continuing. So we will try extending the data set to cover more challenging states, and also we try to improve the model to give better accuracy. Thank you for your attention. Do you have any questions?
Thank you very much, Professor Can Bolat, for your
Sure.
contribution to the Congress. Dear participants, do you have any questions about presentation? I guess there are no questions. Thank you again for your contribution. We will go on
Okay, thank you.
with the, thank you very much. We will go on with the next keynote speaker, Professor Tanupriya Chaudhary. Welcome, Professor.
Thank you very much.
Before
Professor.
starting your presentation, I would like to give some biographical information about Professor Tanupriya Chaudhary. Dr. Tanupriya Chaudhary received his bachelor's degree from West Bengal University of Technology and master's degree from Dr. NGR University, India. He has received his PhD degree in 2016. He has 12 years of experience in teaching as well as in research. Currently, he is working as a senior associate professor in Cluster of Informatics. Recently, he has received Global Outreach Education Award for Excellence in Best Young Researcher 2018. His areas of interest include human computing, soft computing, cloud computing, data mining, etc. He has filed 25 patents till date and received 16 copyrights for his own softwares. He has authored more than 250 papers till date. He has delivered invited talk and guest lectures in different universities. He has been associated with many conferences throughout India. He is a member of IEEE and other renowned technical societies. He is holding the post of Honorary Secretary in Indian Engineering Teachers Association. He is also holding the Senior Advisory position in Confederation of Science, Technology and Research, UK. If you are ready, you can share your screen and start the presentation.
Professor, for your nice introduction. I will request Rohini, first of all, my scholar, to go ahead with the 5 minutes of presentation. Then I'll start my keynote from my end. Rohini, are you there?
Yes,
Sorry.
sir. I am.
Yeah. Please try to conclude within 5 minutes. Then I'll start my keynote.
Sure, sir.
You may please share your screen.
Yes. The screen is.
Yeah,
Sir, is my
visible.
screen is visible?
It's
Okay,
visible.
thank you, sir. Thanks for. Okay. So, good afternoon, everyone. Thanks for accepting from your esteemed conference. So, my paper ID is 68. The title is Optimized Crop Reduction using IoT and Deep Neural Networks. My authors are Tanupriya Chaudhary, Rohini A, and Hussain Fali Mahdi. So nowadays the contemporary agriculture refers to the farming practices. Nowadays we are using that. So it is a more sustainable and the traditional and the modern agriculture we are using this. For this advancement of agriculture, nowadays the food production is increasing a concern. Nowadays the soils are becoming that due to some fertilizer, the soils becomes good in agriculture farming. For that reason, nowadays we are focusing for the modern agriculture. So in this way, we are focusing on the hydroponics. So these practices may or may not be sustainable. For these practices, we can grow more fruits and vegetables also. For example, tomato, turnip. So these are the plants we can able to grow in the hydroponic system. So in this hydroponic system, we can integrate with that IoT. For that machine to machine translation also we can do on that by using in this IoT in agriculture. So for that solution has given that contemporary problems of calcium deficiency, lack of airflow around plants and so on. So calcium deficiency is in the soil. So in this we can able to manage in that hydroponic system. For that reason, the study is a very challenging effect for that agriculture. introduction. So this is agriculture is the significant source of India. So it is an increasing demand for the food laborers also. So it may different practices can be used to achieve the sustainability of that agri nowadays. For that use of that hydroponic system, we can the synthetic pesticides, fertilizers, conserving water, protecting soil, our health using more efficient, less pollution form of energy. We can able to maintain the hydroponic system. I mean, it's full of water contents only. We are growing by this water contents only. We are growing the plant. That is the reason. So there is a no pollution for that. So it is one of the major ecosystem is developing here. The IoT-based hydroponic system, it monitors the automatic actions of the system for the intensity of a light. It is we are growing the plants in the rooms only. So for that reason, there's some attribute, the intensity of a light, electrical conductivity, water temperature, and humidity. So these are all the maintaining in that hydroponic system. By using that information only, we are growing we can grow the plants in that hydroponics way. Okay, in this, there are the 4 types of ponic systems: is the hydroponic, aeroponic, then one more modern ponics also will be there. So in this way, the hydroponic system is a
Sorry to interrupt. Only we can see your slide number 3 only. Can you please
yes, sir,
go
it's
ahead?
a slide number 3 only. It is the introduction part.
Okay. Go ahead.
Okay. So in the sustainable agriculture, so by this way, we have taken the literature survey for the last 3 years. So in this analyzing the smart farming system, they have used it for the hydroponic system only that intensity control, humidity, hydrogen level, water level. So these are the parameters they have used and analyzed that analyze the system by using of the deep learning neural networks. Also, they have data in that. So by this analyzation, the author have used during the Bayesian network they have used. The second author has focused on the potent hydrogen, the pH level they have used for that for analyzing that testing by using of the electrical conductivity results of the feed-forward neural network. So it is also based on your deep learning neural network supports for supporting that hydroponic system. So maintaining the parameters values. So what are the input they have taken? Saying the light intensity, plant age, temperature, acid, and base content. So these are the parameters majorly they have taken for analyzing the growth of the plants. So third author also same like that, but they have used there some different controllers. They have ARM7 and microcontroller for the optimal growth of monitoring. They have used. So the 3 others have been used for that 8 hours how the plant has grown. Like that only they have analyzed. By that with light and without light, with water and without water, like that they have analysis has made on that. So in my proposed study also focused on the same thing, the same kind of parameters I have taken. So this is the model of the system I have used, the deep neural network concept only I have used here. So in this I have taken the latitude, proximity, water altitude. So these are the parameters I have analyzed in the water. So water is the main content for the hydroponic system. So for the 3 controllers, if you are analyzing someone, the plant growth will be yield as a that is the ratio. So machine to machine interaction also I have controlling the hydroponic system. So it can be autonomously and autonomously it has to be indicated in our server. So how much it is absorbing the nutrients, how much the calcium contents will be there in that water. So everything I have in that running of the water. Then next how the I am using the microcontroller of the Arduino Raspberry Pi 3 I have used here. So in this implementation, the tomato plant, ESP8266, that controller has been majorly support for automatic hydroponic system. So in the system, I have analyzed for all the values I have been analyzed and stored in the cloud server. So how the values will be there, I am analyzing. With the water is there means how the airflow will be there. So the airflow is the main content for the roots. So for that reason, so 38 to 68% they have correct approximation for the water. So it is maintained when the plant is growing, smoothly. So like that, I have fixed the range for the roots of the plants also, roots of the plants. So it has given the yields of it, some variations of the levels of leaves. There is a support of deep learning algorithm I have used here. So this is the how that controller will be controlling the sensors as well as the plant growth also. Here the water tank plant control. So this is a AC2C controller. So this is more input information I have given to the IoT and the visualization of results showing the I have here. So from water tank I am all the nutrients of the information. Sorry. For all information, asking in the
Rohini, your network, I think, not stable. It's sometimes you are audible and sometimes you're not.
Yes, yes, sir.
Sometimes you are audible and sometimes you are not audible properly.
Sir, actually, due to the poor network, my voice is not able. This is the reason I am not switched on that video also.
Okay. Go ahead, please.
Okay, sir. So it is the proposed work of my interface. So from this proposed work, the growth of the tomato with the water circulation. So these are the yielding effects of it for the number of leaves for the first week, second week. So these are the days also I have counted. So it's for total the 3 days I have taken. For how much the 18 days growth, 21 days and 31 days of the growth of the leaf I have taken here. So the 10 parameters I have taken from the 11 to 18, 10 to 4. So these are the leaves has grown according to that year of the growth of the days. So when I am after I have analyzed it. So with circulation, so most of the things the moving of water. So the water, less calcium is also there. Also, happy growth moved in the 18 days number of leaves. So it is a little bit they are having the good content. The chlorophyll is also it is a very good in the due to the light illumination. So chlorophyll is the main important for the leaves. So for the due to the light illumination, also it is a good for the 18 days of leaves. So somewhat the 21 days when we are moving, it little bit is a very hot. So the growth is also good in the moving of age of 21 days. For 30 days, it's yielding the fruits also. The tomato fruits also it's coming. So the next one, another analysis also I have taken the number of leaf versus number of growth in the moving average of the n number of days. So the days are so for the 18 days, so many leaves are coming from the few plants. So that analysis I have taken. So it is a linearly it has to be come for all the plants. Nearly for 10% I have tried the hydroponic system for reason it is a good accuracy has given for all the leaves. So the growth of the plant is also very good there. So it is the growth of the tomatoes without water circulation. So before that I planted the leaves, the growth of the plant I have analyzed. Now the water circulation of the tomatoes. So for the tomatoes, after the fruit comes, how the leaves will be there. Like that I have the same set of content for the 18, 21 and 31 days also. It also they are maintaining the good leaves on that. So in this sustainable agriculture, so in this way we are forming that agriculture means it has given the 100% the renewable we can focus on that. So the contemporary farming as protecting the good quantity of the fruits as well as the profitable also we can make on it. So hydroponic system is a good for growing the plants, and the eco-friendly we can make it in our system. So it is a smart hydroponic system. So for that conclusion, it is the cultivation of the tomato by using of the nutrient film techniques. For the nutrient film techniques, we are supplying the nutrition for the growth of the plant. So the quality of growth of the plant also actually nearly 96% of accuracy I have taken for that 18. So 18 is that good one. The 21, 30 days I have yielded the fruits also. So it is a good accuracy I have taken. So by plants. So I have yielded the good in 21 to 30 days. Thank you.
Thank you, Rohini. Thank you for your presentation. I think you may stop the sharing. Now I'll sharing my screen.
Thank you, sir.
Yeah. If my screen is visible to all of you, please let me know.
Yes, we can see.
Yeah. Thank you. Thank you very much for, first of all, to provide me the timeline, because tomorrow I'll be having one important meeting that cannot be skipped. Thank you very much. First of all, today, within 30 minutes, I'll share a few of the points which I have done in my research lab, that is artificial intelligence in human computer interface. That's because the coming session on HCI only, that is why I thought to provide a keynote session on this topic. Going behind, what actually today I'll be doing. Today I'll be telling you one of the project which I have done in my lab in brain computer interface. Though the slides are near about 100 and all, but to narrow it down, I'll skip the slides. First of all, to make you understand what actually the brain-computer interface is, BCI is a fast-growing emergent technology in which researchers aim to build a direct channel between the human and the computer. You can see the screen as well. Now, going beyond, what topic actually I'll be presenting to you all today. These facts I'm just skipping. Yeah, I have used deep learning technologies in my BCI Tech. Why, other than this controlling device, different applications and studies of BCIs are already there, like sleep pattern, ADHD, disorders of consciousness, depth of anesthesia, fatigue, mood, and emotions. And few current state of art also have been developed over here, like the current performance of the deep learning models is unclear, whether it can outperform the traditional processing techniques. This is because unlike natural image, where there is the ImageNet dataset as a benchmark, EEG does not have the benchmark dataset till now also. Unfortunately, for the BCI studies, many researchers use private dataset. Acquiring data is more expensive in these days, and annotated data requires different kinds of subject matters. That means if I am a non-vegetarian, the subject matter will be different. If I am vegetarian, the subject matter will be different. If I am taking, I am smoker, then my subject matter will be different. Or if I am drinker, then also my subject matter will be different. Now, to regularize these issues, as the challenges of BCI applications, EEG signals are highly variable, and EEG signal can differ significantly between these subjects and even within the same subject also, as the EEG contains interference from ongoing brain activity and measurement noises also. And these type of noise suggest the use of regularization in order to keep the weights of that network so that small to reduce overfittings. And two common regularization methods for these neural networks are L1 and L2, definitely, which add a penalty to the weights according to their magnitude, and sign dropout technique is very commonly used as well. Now, how these BCI, how deep learning is working. Deep learning has shown significant performance, though in very either works. Someone has used CNN, someone has used neural networks. But in few cases, deep learning has also taken care of. That is why deep learning has shown significant performance in various tasks. It has proven to outperform the traditional ML techniques that use handcrafted features. And decoding the brain electrical activity with this high variability and non-stationary noise into a meaningful signal is generally difficult. That is why we have used. And these difficulties lead to use machine learning algorithms to solve these BCI applications. I am giving you a simple example. How deep learning works with BCI. Is the capital of Tamil Nadu is Coimbatore? Or is the capital of Tamil Nadu is Chennai? Or is the capital of Tamil Nadu is Madurai? Or is the capital of Tamil Nadu is Vellore? If we are providing these answers, the questions, and I am from India, I know the capital of Tamil Nadu is Chennai. And in such a way, while I'll be thinking about Chennai, the sequence of the order will come like this: A, B, A, and C. As because this is the right answer. For the other cases, which I have been given in the red, the answer will not be right. It will come like this. Now, to be continued, these deep learning has the ability to extract the features and learn from hierarchical representations from high dimensional data, and has led to many real-world applications in the area of computer vision and also in NLP. And given its effectiveness in other fields, the deep learning seems promising to learn from raw EEG data to extract better features to improve the performance and also the robustness. And that is why, in order to tackle these challenges, BCI applications and researchers work on to improve extraction of essential features and from EEG signals and to build models that can generalize us better. And also there are some problems with deep learning in BCI applications that also to be taken care of, as training a deep learning model generally requires a large training data set. Unlike the computer vision research community, where a vast amount of data is available, limited BCI data available pose a challenge. That is why this is also still a great challenge to advance the field forward. And by the help of the conference, we can commute these informations to the researchers as well, so that they can work on this field if they're interested on that. And high quality data is also challenging to acquire. Augmenting data sets or use of generative adversarial network GAN might be adopted. And deep learning models are great in memorizing data set, but given that EEG has a low signals to noise ratio, and sometimes the frequency will not come properly. And that is why we are using 1020 international systems. And by the help of these models might memorize noise data. As a result, the performance is greatly affected, even with various regularization techniques. Now coming forward, some methods which we have used, like restricted Boltzmann machine, RBM it is called. And sometimes we have used RNN, recurrent neural network. These thing needs to be clearly explained due to time constraint. I am not explaining this. If you are having these recording, you may use this recording later, and you can understand the basic characteristics of these methods as well. Now, in the contribution of this BCI, the researchers need to develop more robust and consistent algorithms that can be easily trained and deployed. The algorithms must be able to work with small training samples that can handle noisy signals, that can generalize well on users over different time as well as mood, and generalize well over different users as well. Many studies are evaluated offline on a small number of subjects, but for actual BCI applications to work, machine learning need to work in a real time. Some challenging fields have been given over here, like in neuroscience, signal processing, ML, computational intelligence, cognitive, and physics. Now, which case study? That is why before going to case study, I have just giving you some introductory part by the help of this deep learning and the different kinds of algorithm and state-of-art algorithms. Now I have worked with, I'm having, I think, near about 20 minutes of time. I have worked in bio-inspired brain-computer interface learning style inventory to increase the e-learning efficiency using ML, as because earlier in COVID days, all the institutes and universities are taking the classes on online mode. That is why we have trained these informations as well. These are the MOOCs, that means massive online open courses in India and also in China. Though these statistics do not include China, you can see since 2013 to 2019 and so on, in COVID days, it's on peak. There are some types of e-learning. One is synchronous. This mode of e-learning delivery allows real-time interaction between both the parties, learner and instructor. And these form of delivery could be in the form of multicast web seminars, which is called as webinar. And another one is asynchronous. And this mode of delivery does not allow real-time interaction between the student and the instructor. These form of delivery channels could be through like LMS or Blackboard or like MOOCs. In the e-learning, what actually we have taken care of, the pedagogical technology, policy and research here, new innovation, redesigning, we are usability, acceptance, ongoing evaluation, formal and informal assessment, and there are some design issues which needs to be taken care of. Now you can see how we learn, difference between learners' brain activity. Each learner brain is organized in a unique way. Each learner has a complex and dynamic profile of strength and limitations. Learning styles have been given. A researcher recognized that each person prefers different styles and techniques. Learning style group common ways that people learn. Interestingly, there have been more efforts at advancing technologies than on attempting to understand the needs and the learning style of individual learners and instructional designs also. That is why the most commonly used information was VARC. These are the styles, models with number of articles. Using the VARC, there are a number of articles are there. That is why in learner style also, introvert and extrovert personality traits are there. We all know that. The differences between these introvert and extrovert, I have been given it to you here. And the stimulus in the brain also, how the processing is going on in the brain, I have been given also. Now, we have to provide some scientific evidence also. That is why for introverts, stimulation travels through a long and a complicated pathway through many areas of the brain, including the right from the Broca's area, self-talk and insular, empathy, and left hippocampus personally. And introverts may process information more thoroughly and deeply than the extroverts. That is why the diagram has been given for introverts and extroverts. And that is a diagram of introvert and extrovert brain differences. Clearly, I have been given like 1, 2, 3, 4 will definitely provide us the information, how the information is fetching or going from one portion to another portion. And there are some other learner styles also, visual learners, auditory learners. And also you can see in the William C. Bradford research paper, 65% there are the visual, 30% are auditory, and 5% only the experimental researchers or learners. And in this work, we have also made one chatbot. In the field of e-learning, the application of the chatbot as part of the education has shown interesting potential both as a teaching and an administrative tool. Chatbots have been trending for a few years, and quite a few papers examining them in the educational sector have been published, and very little interest seems to have been given to the summation of this knowledge. I think there is any question, or I should go ahead. Okay, then I think if there is no question, I should go ahead, or there is any chat. Okay, thank you. While explaining the chatbot in e-learning, the theme I have been given, what are the role of the bot, what are the features of the bot, and what are the sub-theme of the found in the chat. The basic problem statement which we have done and from where we have taken, the researchers are attempting to decrease the dropout of e-learning process in various methods earlier, before COVID. And recent study, it has been found by MIT that astronomical dropout rate about 96% was found in the last 4 or 5 years before COVID. And then if my screen is visible now, again. Okay, thank you. Now again, there is a need in human-computer interface to use the BCI with learning style to increase the efficiency of the e-learning. And there is need to explore the possible method to group the learners into personality traits and learning styles also. And already I have been given the motivation of the research. Now I'm just telling you what are the objectives. Within 15 minutes, I'll complete. To use the chatbot instead of survey questionnaires for e-learning, to record the brain signals using BCI for learner classification, and to find out the correlation between learning styles and personality traits using ML algorithms. Already, I have already given the information about VARC. In the proposed chatbot, which is bio-inspired, the proposed chatbot has loop of questions that are divided into 3 parts: learner general likes and dislikes, learner day-to-day unique habits, and learner preferences on learning. Basically, initially modified VARC questionnaires are implemented as a chatbot to classify the individuals as they are visual or auditory. Then the chatbot is intended to know the learner preferences manually. The conversation of the bot in chatbot is likely to interact with the learner to know the basic information like age group, habits, and learning preferences. Then the chatbot interacts with the learner to classify them into introvert and extrovert. This is a basic bio-inspired chatbot flowchart which we have proposed, has been given. By the help of this, we have developed this chatbot. The experimentation which we have done has been already given here. Here, 118 learners from SRM Institute of Technology in Chennai, they were there in India. And as per the data flow of the proposed chatbot, the implementation is performed using the LandBot online tool, which is a tool for creating online interference for chatbot. This is some screenshots by using Tamil language you can see, and also some English language is also there. While classifying the informations, we can have within 118, extrovert were 56, introvert were 47. Not to classify, that means ambivert was 15. And average time taken near about 3.53 minutes. I have been given in the graphical representation also. And to record the brain signals using BCI for learner classification, how we have done. As because I have been given why we have used BCI, the hardwares we have used BCI devices is able to connect the mobile devices like iPhone and Android. We have used 1020 international system. Some details of the participants have been given. A total 118 healthy learners are chosen for this experiment in the age group between 18 to 79 years. They are requested to watch the sample audio and video learning contents, and the learner participated in the study in the SRM in India. How we have prepared the data set. The learners are seated in a silent atmosphere. As per the international guidelines, learners are requested to take a long breath, at least 10 times before they are allowed to record their own EEG signals. What are the tools for the BCI? We have been given the receiver side, the mobile device is a mobile application called EEG ID. In the right hand side, I have been given the screenshot of EEG ID. It is very lightweight application and it can connect with NeuroSky device with Bluetooth connection. And EEG ID using EEG signals can be recorded at intervals of minutes, seconds, and milliseconds. Then the learner can generate the BCI waves, and that will be converted into CSV file using through EEG ID mobile application. Some sample video content have been given there for visual and auditory learners. The brain waves are coming out like this. While watching the sample audio visual content, each learner produces beta waves. There are three types of waves generally: alpha, beta, and gamma. And each learner generally produces beta waves for every second continuously. Once the learner calm down themselves, the testing sample contents are shown one by one to all these 118 learners, and beta waves are produced in the range of 180 Hz to 16,776 Hz. Some observations which we have taken. It is observed that every learner had produced a unique EEG brainwave. During the testing, it is clear that introverts produce highly magnitude of beta wave during the initial period when the visual contents are shown, whereas the extroverts produce low amplitude beta waves during the initial period when the visual contents were shown. Ambiverts produce lesser modulation of beta waves during the entire testing period. Some normalization of beta waves, how we have done, some pseudocode have been given for better understanding. How the EEG brainwaves have quite large variation, and EEG brainwave datasets are to be normalized before proceeding for the general classification. The dataset after normalization were the value and the count instances we have 14,396. The minimum value we have taken from 1 to maximum 4. The mean value was coming 2.407 and the SD was come 2.262. Now to find out the correlation between these learning style and the personality traits using ML, how we are doing. These are the training data. From here, ML algorithms is coming, and we are classifying the information from the test data, and then we are evaluating the results. Some tools for comparison we have been given: Weka, RapidMiner, R programming, and Orange. During machine learning with Weka, the training while giving 15 introverts, 15 extroverts, and 10 ambiverts, and testing of 118 instances, since the dataset are generated time dependent. That is why we have used Naive Bayes and J48 classification in the decision tree. Algorithms are applied to the dataset, and some confusion metrics are formed. These are the parameters while using the classification by Naive Bayes in the BCI dataset of 118 learner is applied to the Naive Bayes classification algorithm available in the Weka tool. There are the correctly classified instances were 110, near about 93% of accuracy. Incorrectly classified cluster near about 8, which is 6% of that error. Mean absolute error is 0.88. Root mean square is 0.04, which have been given in the slides. While using classifying these information by naive Bayes, this is the confusion matrix we have been given. Classification of this J48, the values have been clearly given. Same for J48, this confusion matrix. While giving the proposed bioinformation or bio-inspired chatbot, that was provided some good results, which have been annotated. Definitely, the procedures we have to take care about overfitting. Detecting the overfitting is useful. That is why cross-validation is a powerful measurement tool against this overfitting. And the classic way to avoid this overfitting is to divide the data sets into different groups, like 3 groups we have taken: training set, test set, and the validation set. To validate the overfitting clustering algorithm is applied by removing the labels in the data set. That is why we have been used canopy algorithm. Some information of comparison have been given over here. At last, we can see that the machine learning algorithms are useful for validating the classification of learning style inventory with personality traits of the introvert and extrovert. The proposed bio-inspired chatbot method gives good accuracy classification of the learners than the existing work method. It has been observed that introverts and also the extroverts learner prefers auditory contents from the BCI experiments. Now, thank you very much. I'm just showing a few of the works which I have been done. And these are the works are progress in my laboratory. If you want to go for some collaboration, definitely you are welcome. And these are the few of the books which I have been written and also edited, and the journals which I'm taking care as a editor and a sub guest editor. I have been given in the right-hand side. Thank you very much. And one information just to showcase to you. These are a few of the citations I have been given. If you want, and if your research is aligned to my research, we can go ahead in collaboration. And also in the Scopus preview I have been given, you can check it out. Thank you very much. Yeah.
Thank you very much for your presentation. Dear participants, do you have any questions about this topic? I guess there are no questions. Thank you again for your scientific contribution to the Congress. I am now ending the session.
Thank you, Professor. Thank you very much for giving us the time. Thank you.